Okay, good. Then thank you very much, and good afternoon, and welcome to the session, when to stop tuning a query. My name is Milos Radivojevic. I'm from Vienna. I'm responsible for database development in BV, the largest online betting company. We have only 10 minutes, so let me introduce sample tables that I will use in this session. It's a very simple data mart. The parent table A has 100 million rows. The child table B has 335 million rows. There is a foreign key relationship over the column PID. And we have 3 to 4 rows from A in B. So in average, so distribution is more or less unified. There are no spikes and such things. Both tables have a cluster index on the ID column and non-cluster indexes on the PID columns. All indexes and stats are up to date. Database compat level is 140, which corresponds to SQL Server 2017. And here is my simple query. It's a very simple one. Is basically I want to see all rows where PID in the column in the table A has this value. So the query is very selective. It returns 856 rows only out of all these millions. So very straightforward situation. What can go wrong with this query? Let me execute it. So I'll execute this query now. So it's run about 2 seconds. So when you look at the execution plan, you can see here hash match join. And here's this huge line representing my table B. You can see here 335 million rows. So I have 64 gig in this working station, so it is quick, but basically this is a very slow query, actually very resource intensive query. When you look at this plan here in message tab, you can see about 5 million logical reads and 13 seconds of CPU time, about 2 seconds of execution time. For very simple query, very selective one. So SQL Server has chosen hash match join operator, which is more appropriate for low selected queries. So something is wrong here. What we expected is nested loop join. And what we are doing when we expect or when we are sure that the plan based on nested loop join is a good choice for our query, to use the loop hint, right? Inner loop join. When I execute this now with inner loop join, everything seems to be fine. So I can see here nested loops join. I wanted to have this. When I look at the messages tab, I can see instead of 5 million logical reads, now it's about 7,000. And elapsed time is 85 milliseconds, no CPU time. Actually, everything was done quickly as we expected for the first time. What is wrong here? So nothing is wrong, and most of the developers will stop tuning here because we solved the problem. However, when we look at the more details in the plan, and we do not look at the more details when we have fast execution, just when somebody claimed, when you look at the left corner here, when I see here on this select, we can see that this query got almost 10 gigabytes of data, 10 gigabytes of memory grant. So SQL Server reserves 10 gigabytes of memory for each query execution. Fortunately, because of the loop hint, this execution is fast. The memory is back to the system very soon. But this could be a huge issue when you have a frequently executed query from multiple sessions. I will simulate now this with SQL Query Stress tool from Other Mechanic. So I will execute the very same query 100 times with 100 parallel threads. So it's running now. When you look at the wait stats, we can see very good resource semaphore waits. What happens now? SQL Server doesn't have enough memory to serve all these requests, and all these queries have to wait. And this will take about, I don't know, 25, 26 seconds. And this is not a problem for this particular query, but for all queries within the system, because memory is shared resource, 24 seconds. What can we do here? This is the second workaround. Now I have to limit this memory, because I know that my query will not return more than a few thousand rows, regardless of the parameter that I use. And I can use here option max grant percent equal 0.01. It means it will use not more than 0.01% of server memory. And when I execute this again, 100 times in 100 parallel sessions, you can see here CS packet waits. There's no resource semaphore waits anymore. And the execution is faster. It was 24 seconds. Now it's about 9 seconds. So we made a second workaround to our initial query. And even we can get rid of parallelisms because of this query is quick enough, and basically we have no large data volume to be processed. So we can even put another hint, maxstop 1. Stop 1. And let me execute this again. Again, 100 times, 100 parallel sessions, and you can see here just async network I/O, so almost nothing from memory, and 6.8 seconds. The entire workload is done. So what I did, I implemented 3 workarounds for very same query. Now this query can be interpreted as safe for the system because I have limited memory. By using this hint, I just instructed SQL Server to use this particular join operator, and I even disable parallelisms for this particular query. This can be lived in the system, but this is a still workaround. So we did not implement solution, but just workarounds, 3 workarounds. We are done with urgent tuning under pressure. Now we can relax and make a proper tuning, which includes finding the root cause for the issue and to have time for analysis. And the root cause for this issue is wrong statistics for large tables. Due to wrong values in the statistics object, SQL Server significantly overestimated number of rows that needs to be processed. When you look here, you can see that SQL Server expected 32,000 rows and only 288 are returned. And this is a huge issue. With all these hints, we did nothing to the estimation. We just overrode some decisions of optimizer, but we did not touch the estimation. So how to deal with estimation? It's a 4th workaround. And 4th workaround is to split this query, even simple query, to put first part in the table variable and then to join table variable with the table B. What I did with this, let me execute this query. Now with this huge overestimation, I just put a table variable, and table variable has a property which I used or misused in this case, that table variable cardinality is 1. And I'm wrong in the other direction, and it looks great in the final query because this, instead of 32,000, now I have 1. This is estimated number of rows, it's just 1. Here I had 33,000, and this underestimation with overestimation from here results with a great estimation. So I tricked the optimizer and I got 861 against 8. This is almost identical to the actual number of rows. And here I don't need any hints, I don't need anything, I tricked the optimizer. However, when you look to the when you switch to SQL Server 2019, there is a feature called table variable defer compilation, which could break my workaround here. It's still feasible. I still get nested loops join, but now it's a parallel, and you can see here a different kind of estimation. Now it's 250,000. So it's basically significantly more. So sometimes new version can break your workaround, but this is still workaround. All these things which I presented until now, it's our workarounds. The real problem here are wrong statistics, and the solution that can change, and the solution for this problem, not the workaround, is update statistics AX1 with full scan, or it doesn't need to be full scan, but this should be some large sample of the table. So default statistic for large table is 0.0 some percentage of this rows, and when you have a ascending key in the statistics, this can be very wrong. So when you execute this, it will be 10-15 seconds, and go back to our initial query. So without any hint, so it's done. our initial query will work. So SQL Server comes with nested loops join. So this is a basically final solution for this problem. Okay, I think I'm done. So I will be available for Q&As in the next 5 minutes. Thanks for your attention and enjoy the rest of the conference.